So welcome to part 2. In part 1, I went over some of the most common errors I see when answering stats fraction questions. In this video, I'm going to run through how to actually solve the questions correctly, and I'm going to be looking at the fractions questions that appear in paper 1, the arithmetic paper. Paper 2 and 3, the reasoning papers, I will cover in part 3 of this video series. If you want to have a go at these questions, just click the link and you can have a go at the questions before you watch this. For an addition question with fractions, the most important thing is that we need to be making sure that the denominators are the same. We can't add this yet because our denominators are different. Can't add a fraction that has a 4 and a 6. So we need to find a common multiple of both denominators, 4 and 6, so that we can find the equivalent fractions of 3/4 and 5/6 that will have matching denominators. So we need to make the denominators the same, but we can't just change the value, okay? So we would look at 4 and 6. A very quick way to do this is just to times them by each other. So 4 multiplied by 6 is 24. Those are a common multiple of both fractions, so I can easily find what 3/4 is if I found it as with a denominator of 24. However, there is a lower common multiple of these. And sometimes your children will be really good at finding those, and sometimes it's easier just to multiply the two together. Either works. I prefer to find the lower common multiple, so I'm going to show it to you if we changed both so that they were multiples of 12. So if I compare my 4 to the 12 and I think about what I multiplied it by 3, so I'm going to do the same to the numerator. So 3/4 would become 9/12. My 6 only had to double to make 12, so I'm going to do the same to my numerator, the 5, so that becomes 10. I can now add them because they have the same denominator. And the other common error, which I didn't mention earlier, is we don't need to add the denominators. Don't add 12 plus 12. The denominator in a subtraction and addition question stays the same. We only add the numerator, which is 19. Now 19/12 can't be simplified because 19 is a prime number. However, you might notice the numerator is larger than the denominator, so this can be changed into a mixed number. I'm not going to go into that with this question because I will be going into that a little bit more with question 5 and 6. So my answer to this is 19/12. With a subtraction question, we also need our denominators to be the same. So we need the 3 and 5. We need to find a common multiple of both 3 and 5. In this instance, I am going to just multiply them both by each other. So 2/3 and 2/5 will both become fractions over 15. So I'll write in the denominator first once I've decided what that is, put my subtraction symbol in the middle so I don't accidentally add, which I've seen a lot as well. And then I just look at my denominators. Well, here I times by 5. I just times by the other denominator, but I just pop it in there anyway. So 2 we times by 5, which is 10, and then on the right hand side, my 5 I multiply by 3, which is the other denominator. So my 2 I also multiply by 3, which is 6. Now remember, we don't need to do anything to the denominator. If it is the same, we can simply write the denominator in over the other side. We just subtract the numerator. 10 subtract 6 is 4. And that is your final answer. We cannot simplify it because 4 and 15 do not have any common factors. So our final answer is not 14. Our final answer is 4/15. Question 3, our multiplication. This is the loveliest of fraction skills, in my opinion, because we don't have to do any changing. Often we will look at this, children will look at this and think, oh, we need to find our common denominator, we're going to multiply 8 by 9 and change the whole fraction. We don't need to do that. With multiplying, you simply multiply the bottom and multiply the top. So we just do 3 times 6 is 18, and 8 times 9 is 72. Now this can be simplified. You don't always have to simplify your fractions. If it tells you to simplify it.
What can happen though is if this is the correct answer and then you simplify it and you get the wrong answer when you simplify it, you lose marks. So if you're not very comfortable with that and it doesn't ask you to do it, just leave it like that. But if you were to simplify this, a few different strategies. If it's an even number, just keep halving it. Find the highest common factor. You might think, oh, these are both from the 9 times table, so you could divide both by 9. Just keep cancelling down until you can't cancel down anymore. I can tell you both of these are in the 18 times table, so I can just cancel it down. It actually becomes 1/4. But that is a skill in itself to simplify, which I have lessons on if that's what you need to do. But I would leave that as 1872 unless it actually asks you to simplify it and you're not confident at doing that. Next question is a division question. With division, we are actually going to be using the multiply fraction skill. We are going to be switching this around a little bit. I call it the KCF method. I have heard some children say that they call it KFC in their schools. That might be because KFC is a more memorable acronym. I personally don't call it KFC because the order of it is to keep, change, and flip if you are reading from left to right. You keep the first fraction, that stays as 5/8. You change the division to a multiplication and you flip the second fraction, so you just turn it upside down to 3/2 or 3/2. You then treat this as you did the multiplication question in the previous slide. Times the top, 5 times 3 is 15, times the bottom, 8 times 2 is 16, and that is it for a division question. Keep the first bit, change it to a multiply, flip it over, multiply top and bottom. This doesn't need simplifying. 15 and 16 do not have any common factors. Okay, so for these questions where we are calculating with mixed numbers, my preference is to change your mixed numbers to improper fractions first because I believe that gives you more accuracy. However, I know a lot of children are partitioning them and then adding them, so I'm going to actually show you how to do it if you stick with that method, but what to watch out for so you don't commit the same error that you will have seen in part 1 if you watch part 1 of this videos. So we can certainly separate our whole numbers and our fractions. So we know 1 plus 1 equals 2, and we need to remember to add that back in first of all, and we can do our 3/6 plus our 5/9 separately. We can't add them as they are, so we're going to find equivalent fractions. So this is, I'm going to make them both have fraction denominators of 18, and that would be 19/18. So far all of these calculations are correct. We then need to combine our answer from our whole numbers, our integers, and our answers from our fractions. However, if you watch the common error video, we often just see 2 and 19/18 put together. We cannot do that because 19/18 is an improper fraction. So before we can add this together, we actually need to separate the integers from this fraction. So this is not a proper fraction because the numerator is larger. 19/18 is equivalent to 1 and 1/18. We can now combine these. So, sorry, I have done these the wrong colours to confuse you. So if I actually that 19/18 as like a purpley colour, because it's not a proper fraction, it's not an integer, it is in fact an improper fraction. So we have our proper fraction there, and then we actually have a integer there. So when we look at our final answer, so 19/18 is equivalent to 1/18, but we've also got the 2 to add. So we need to combine our whole numbers. We've got 2 and 1, so that makes 3, and then we put our fraction next to it. So if we are adding with mixed numbers and you are partitioning them into integers and fractions, you need to make sure when you add your fractions that if that becomes an improper fraction, you change that to a mixed number. You've either got to do the whole thing as improper fractions, or if you're using your mixed numbers and partition, you need to make sure you're watching out. We cannot have a whole number and an improper fraction. That's not a correct value. A mixed number is made up of a number and a fraction. An improper fraction is made up of a numerator that is larger than a denominator. You cannot have like a combination, like a hybrid. That is my top tip for this question. So here we have a subtraction problem, and in part 1 of this video I showed how if you partitioned and then recombined this answer, it's really easy to make a mistake. So for this one, I'm actually going to change each one to an improper fraction, which is my recommendation for calculations with mixed numbers. I just recommend always changing them to improper fractions first. So I've just moved it out the way a little bit. So if you are not sure how to change mixed numbers to improper fractions or improper fractions to mixed numbers, this is a really key skill that does need to be acquired before sitting the SATs. I'm going to sort of go over it very, very briefly, but if that is something you need to know, then please do let me know. I've got lots of resources on these things. So I'll go through it very quickly now though. So I'm going to take my whole number, multiply it by my denominator, and then add the numerator. So 2 times 5 is 10, plus 1 is 11. That's my numerator. The denominator stays the same. And subtract. 1 times 2 is 2, plus 1 is 3. So that's 3. The numerator stays the same. Now I've got 11 fifths take away 3 halves. I can't do that, can I? Because my denominators are not the same. So I need to find the common factor. I'm going to change them both to 10 because 10 is a common multiple of 5 and 2. Remember to put my subtract in. My left hand side I'm going to times it by 2. My right hand side I'm going to times it by 5. I can now subtract this. The 10 stays the same. 22 subtract 15 is 7. So my final answer is 7/10. You may have seen the common errors video where this answer was written as 1 3/10, and you may or may not have spotted that in the partitioning video they added 3/10 because they tried to subtract a bigger number from a smaller value and they switched them round. When actually it needed to be 3/10 taken away from 1, which is why the answer is 7/10. So hopefully you found some of these appropriate methods useful. If you do need any help on any of the skills you've seen here, if you've made any of the same errors as the common error video, if some of these methods are completely new, then the Focus on Fraction course is a really useful one. It just goes over each of the skills for addition, subtraction, multiplication, division in a really clear way that builds up step by step, and it's perfect revision for the SATs. Stay tuned for part 3 where I will go over some of the fraction skills that appear in the reasoning paper. Don't forget you can actually download all the questions in these videos for free so your children can have a go for themselves to see where their strengths and weaknesses lie.